Okay, we're moving on to section 5.2. 5.2 is a pretty big section. It's going to take us a couple days to go through it. So there's going to be two videos for section 5.2. This first video you're watching now is going to cover the first two essential questions here. What are polynomial functions and how do you evaluate polynomial functions? And then the second video we're going to look into how do you graph polynomial functions. So it's a little bit of a longer section, so I want to break it into two separate videos, and it's kind of new stuff, so it's pretty important. So the first question, what are polynomial functions? Here's the definition right from your book. Polynomial is a monomial or sum of monomials. Of course, then you need to know what a monomial is. So a monomial is a number, a variable, or a product of numbers and variables. So an example would be 3x squared. That is a product of a number and variables. Okay, so basically it's just an algebraic term that it's either a number or a variable or a combination of those. So a polynomial then would be a string of these numbers. So an example of a polynomial might be 5x cubed minus 3x squared plus 2x minus 7. That would be a polynomial. It is a sum or difference, doesn't matter, addition or subtraction, of a string of monomials. Okay. So in general, this is in your book, a polynomial looks like this. And this looks a little bit confusing with the variables. You'd read this: f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 all the way down to a1x plus a0. Okay. All this is basically is n is the biggest exponent, and n is called the degree. The degree is the biggest exponent. So typically, to write a polynomial properly, you start with the biggest exponent and you decrease from there. So the example I wrote here, we got a cubed, a squared, x to the 1 power, and then the constant. Okay, so this would be 3, 2, 1, and then the constant at the end. A sub 0 is the constant term. So don't get hung up with this little bit of a confusing expression here. This is just in general. Okay, so we're going to look at some examples of polynomials. Now the big key, the most important thing, polynomial functions have whole number exponents. Okay, whole numbers. What are whole numbers? Whole numbers are the counting numbers 1, 2, 3, 4, and so on. Okay, we cannot have any negative exponents. We can't have any fractional exponents or decimals or anything like that. Okay, so that's the key. So in your book on page 337, I'm going to slide my book over here, is a chart, common polynomial functions. So this is, and they have special names. Okay, so a degree 0 is just a constant. So just having a number like f of x equals negative 14 is technically a polynomial of degree 0. Okay, degree 1 means it just has an x term. It's linear. 5x minus 7, because the biggest exponent is a 1. Okay, a squared, or a degree 2, is a quadratic. It has a squared term in it, like this one, 2x squared plus x minus 9. A cubed, or a degree 3, is a cubic. Okay, so that would have a highest exponent as a cubed, like this one here. And then fourth degree is called a quartic. Okay, so it has a fourth power. Okay, now a polynomial doesn't have to have every exponent. Like this one is x to the 4 plus 2x to the 1 minus x. So it doesn't have a cubed or squared term. That's okay. It's still a polynomial. Okay, so let's look at this example 1. It's asking you to decide whether the polynomial is a polynomial function or not, and then state its degree, type, and leading coefficient. So looking at the first one, you got to ask yourself every time, are the exponents whole numbers? So I have a 4 and a 2 as my exponents. Okay, those are whole numbers, so this is a polynomial function. The degree is 4. The leading coefficient is the coefficient of the monomial with the biggest degree. So in this case it would be 1 because there's no number in front of the x to the 4. Okay, so that's going to be important when we start graphing. The degree and the leading coefficient is going to tell us the shape of our graph. Okay, let's look at b. What's the biggest exponent? Squared. So this is a degree 2. It's a quadratic, and the leading coefficient is pi. This one here, this one is not a polynomial function because it has a negative exponent. Okay. This one here, this one has x in the exponent. X is not a whole number, so this one is also not a polynomial function. Okay, so you can see how you identify those things. Okay. Oops. So you guys, I'm going to write 3 of them here, and you tell me whether they're polynomial functions or not. So you think about it, and then we'll answer them. So the first one, okay, so look at those, decide whether they are polynomial functions or not. What's the degree? What's the leading coefficient? Okay, so looking at the first one, this one is, the degree is 1 because the biggest exponent is 1. The leading coefficient is -2. Second one, this one is not a polynomial function because of the negative exponent. Third one, this one is a polynomial function because it has whole number exponents. Even though the constant term is not a whole number, that's okay. It's the exponents. So we got a squared and a 1 power. So this is a degree 2. It's quadratic. Leading coefficient is 6. Okay, so we were able to identify polynomial functions. Now the next part of this section is about evaluating polynomial functions. Okay, so I'm going to start on the page here. So there's 2 ways we're going to evaluate polynomial functions. One is called direct substitution, and one is called synthetic substitution. Okay, so we'll do examples of both. Okay, so for example, let's say our function is this. Okay, and we want to find out what f of -2 is. Okay, so remember, function notation, the number in here is the number we plug into each of the x's. So that's direct substitution. When you just directly substitute the number in for the variables and figure out what the answer is. Evaluating a polynomial function means just plugging a number in and figuring out the answer. Okay, so let's plug -2 and see what we get. -2 to the 4th, 2 times -2 to the 3rd. Okay, so -2 to the 4th would be -2 times -2 times -2 times -2. So that would be 16, I believe. -2 cubed would be -2 times -2 times -2 is -8. This will be 4. So then we got 16. This is going to be -16 plus 12 minus 7. So So that's going to be 0. So it's basically, it gives me 5. Okay, so f of negative 2, when I plug negative 2 in there, I get 5. Okay, that's direct substitution. Now synthetic substitution is a little bit unique. What we're going to do here is we're going to draw a little half of a rectangle there. We're going to put the number that we're substituting in on the outside here. Okay. And now we make sure we're in proper order here from biggest exponent down to constant term. And we're going to list x to the 4 is my biggest exponent. So I'm going to put an x to the 4 here. And then I'm going to drop down 1 power and go from 4, 3, 2, 1 to 0. And then I'm going to put the coefficient of each of these variables here. Okay, so x to the 4 has a coefficient of 1. X cubed has a coefficient of 2. X squared coefficient is 3. There is no x to the 1 term. There's no x term, so I'm going to put a 0 there. And then x to the 0 is my constant term, so that's negative 7. So I put that there. Okay? So that's how I set this up. Now I drop this down, this number down, comes down here. Then I multiply. Negative 2 times 1 is negative 2, and I put that right here. Then I add. I get 0 there. Then I multiply. I get 0. Then I add. I get 3. Then I multiply here and I get negative 6. Then I add. I get negative 6. Then I multiply and I get positive 12. Then I add. That gives me 5. And that number at the end is my answer. It's the same thing I got there. So it's kind of a unique way to do this. The reason it comes in handy is all you have to be able to do is multiply and add. Whereas this process, if you have some bigger numbers and you're trying to take a bigger number and take it to the 4th power, the 3rd power, it gets a little more difficult. So by hand, sometimes synthetic substitution becomes easier. Okay, so let's just do one more. Let's say we've got and we want to find g of 4. Okay, so go ahead and try to do it both ways. Pause the video, see what you get, and then we'll go through it. Okay, so if I'm doing direct substitution, I have 4 cubed, 5 times 4 squared, 6 times 4 plus 1. Okay, so 4 cubed, 4 times 4 is 16. 16 times 4 is 64. 4 squared is 16. 16 times 5 is 80. Plus 24 plus 1. Okay, so let's see, we've got 64 minus 80 is negative 16. This would be plus 24 is 8, plus 1 is 9. I get 9. Okay, try synthetic. Number I plug in is 4. X cubed is my biggest power. Cubed squared 1 0, so I've got a 1, a negative 5, oops, and then my x to the 1 term is 6, my constant is 1. Okay, so remember, if I'm missing any of those, you put a 0 in there. So drop the 1 down and we multiply. 4 times 1 is 4. Add those, I get negative 1. Multiply. Negative 4. Add those. 6 and negative 4 is 2. Multiply those, I get 8. Add those, I get 9. 9 is my answer. Now, which math was easier? The multiplication and addition here was much easier than this process, so that's where it comes in a little bit handy. It's also going to come in handy in later sections when we do some synthetic division. So that is the first part of section 5.2. The second video is going to be on graphing.